In this short video, we'll take a look at atomic structure, specifically the subatomic particles that make up the atom. Here's a diagram of the atom, a simplified diagram that is often referred to as the Bohr model. And what you see is the nucleus. So in the center, you have the nucleus, which is actually very, very small and in the very center of the atom, but it makes up the vast majority of the mass of the atom. And then you see surrounding the nucleus the orbits of the electrons. So in the nucleus, you have the protons, which I've got here in blue. The protons have a positive charge. It's a +1 charge relative to the charge of the electron, which has a -1 charge. So in a neutral atom, you should have the same number of protons and electrons. The neutrons have no charge. They are also in the nucleus. So the neutrons don't have a charge. They have a net charge of 0, but they do have mass. So the protons and the neutrons make up the vast majority of the mass of the atom. The proton has a mass of 1 atomic mass unit. So an atomic mass unit is defined as 1/12 the mass of a carbon-12 atom. And we'll talk about what a carbon-12 atom is in just a second. The neutron has just a very slightly larger mass than the proton. So it's very, very slightly heavier, but they're both approximately 1 atomic mass unit, or 1 AMU. So we generally think of those as having the same mass. The electron has a very, very small mass. It's about 1/1800th of an atomic mass unit, so it's very small. Essentially, it's weightless, so when an electron is lost, it doesn't really affect the mass of the atom. It's essentially negligible. So the mass comes from the nucleus. It's the protons and the neutrons. And the nucleus is very, very small. If you were to compare the size of the nucleus with the size of the electron cloud, in a real-world example, if the electron cloud were the size of, say, a football stadium, then the nucleus would be the size of a blueberry in the middle of that football stadium. So the nucleus is very small, but it's where all the mass is in the atom. This atom in the diagram has 6 protons and 6 electrons. So if you look on the periodic table, you would see that it matches with carbon. So this would be an element of carbon, and the number at the top of the box on the periodic table is the atomic number. So the atomic number tells you the number of protons. So for carbon, it's 6, and that is what gives the element its identity. So since carbon has 6 protons, any element that has 6 protons is a carbon atom. This number at the bottom is something else. That is the atomic mass. It's actually the weighted average of the masses of all naturally occurring isotopes. And isotopes are the same atom, so it means it's got the same number of protons, but with a different number of neutrons. So they have a slightly different mass. So for example, carbon has at least 3 different naturally occurring isotopes, carbon-12, carbon-13, and carbon-14. But the most common are carbon-12, which we would write like this. In isotope notation, we write the mass number on the top left, and that has the symbol A. So that's the mass number. The mass number is the number of protons plus the number of neutrons. We often write the atomic number down to the bottom left, which has the symbol Z, that's the number of protons, but often that will be omitted because we can just look at the periodic table and get the atomic number. So often we write these like you see here. We would say that is carbon 12, and that's how we would write it out in words. And carbon 12 has how many neutrons? Well, you take the mass number and you subtract the number of protons, right? So since the mass number is the number of protons plus neutrons, we can take the mass number, so the number of neutrons equals the mass number 12 minus the atomic number 6, so carbon 12 has 6 neutrons. The other common naturally occurring isotope of carbon is carbon 13. So carbon 13 has 13, right? 13 is the mass number, the number of protons plus neutrons. Subtract the number of protons and you get 7. So carbon 13 has one more neutron than the number of protons.